Molaei, Marcus, Geimer, and Antti, Kolu. So, Molaei, are you ready?
Yes, I'm ready.
Okay, so go ahead.
Thank you so much. Thank you for the introduction. Hello, everybody. Good afternoon. Thank you for coming today to listening my presentation. Today, I want to briefly talk about my paper. The topic of my paper is an approach for estimation of swing angle and digging depth during excavation operation. Firstly, I want to say thank you, my other authors, my supervisor, Professor Geimer at Karlsruhe Institute of Technology, and Master Antti Kolu in Novatron Company in Finland. Firstly, we will talk about a general challenge in this field and why do we need to work on this challenge. As probably you know, the heavy-duty mobile machines are one of the most important machines in many applications, particularly the construction applications. There are a lot of challenges in this field for these machines. For example, the lack of skilled human operators, low productivity, and high cost, approximately 5 to 10% of the direct costs in building projects, and up to 40% of direct costs in highway construction projects related to the heavy-duty mobile machines. And also we have other challenges such as harsh environment and safety. But what is the possible solution for these challenges? The productivity improvement. Probably you heard this sentence: if you cannot measure it, you cannot improve it. This is very important sentence. For the productivity improvement, we need a method for the productivity estimation. We need an automatic method for the productivity estimation. What is the advantage of the productivity monitoring? Reduction of the operation time, reduction of the fuel consumption, optimizing the planning, optimization of the planning and working parameters in the construction sites, improvement of the management and economic aspects. Also, human operator can improve their skills by using the feedback from the productivity of the machine, heavy-duty mobile machine. And also, an automatic method for the productivity estimation can be an essential step toward the autonomic excavators or autonomous machines. In this paper, our application is the excavator. Excavator actually is the most important machine in this field, and there are a lot of tasks that the excavator can do, but the excavation, trenching, and grading are three most important tasks. In this paper, we worked on the excavation operation. There are two important factors for the productivity definition for the excavation operation by using an excavator. It is the quantity of transferred material. It can be volume or weight of the material, and also the operation cycle time. We need to know these factors to be able to define the productivity and calculate the productivity. The excavation operation consists of four main subtasks: the digging operation, the digging subtask, swinging loaded, dumping, and swinging empty. We need to know the information about these subtasks. Now, in this slide, I want to talk about what is the influencing parameter or operating condition that can significantly influence the productivity of excavator. Firstly, it is the size of excavator and bucket capacity. Definitely, when the excavator is smaller, it can cycle faster. And also the digging depth. When the material gets deeper, it takes more time to complete the digging subtask. Also, we have the swing angle and dumping condition as an important factor. Also, type of the material and site congestion, skill of the human operator, and weather condition are other factors and parameters that can influence the productivity of excavator in the excavation operation. Probably you heard other wording for the excavation operation, such as loading operation or dig and dump operation. Because we don't have a lot of time, directly we go to our method for the swing angle estimation. You can see the flowchart of the general flowchart for this method. As input, we have the cabin encoder measurements of the excavator, and for the input, we have the swing angle. Firstly, in this algorithm, we apply the moving average filter to reduce the noise and effects of the sudden movements of the machine. After that, we use the local minimum and maximum finders to find all possible points as a scoping and dumping position. Definitely all minimum and maximum points are not the correct solution for the scoping and dumping position. We calculate the prominence value for each local and maximum points. After that, by using the OTSO method, we try to detect the correct minimum and maximum points or the scoping or dumping position. This method is this thresholding method is worked based on the prominence value. And finally, based on the difference between the local maximum and minimum points, we can calculate the swing angle of the operation, swing angle of the excavator in the excavation operation. Now, in this slide, you can see an example for the prominence value. What is the prominence value? Actually, the prominence value of a local minimum point determines its depth compared to the other local minimum points. And also, we have a similar definition for the each local maximum point. Actually, the prominence value of a local maximum point specifies the height of the point with respect to the other local maximum points. In this figure, you can see a simple example for the calculation of the prominence value for a maximum point. And in this figure, you can see the value of the prominence for the maximum points. And now in this slide, you can see the flowchart for the digging depth estimation. For the input, we have the IMU sensor, and for the output, we have the digging depth. In this approach, firstly, we use the measurements of the IMU sensor that already attached on the different parts of the machine, bucket, boom, arm. Firstly, we calculate the position of the bucket based on the kinematics of the machine and IMU sensor, measurements of the IMU sensor. Firstly, we apply the moving average filter to reduce the noise and sudden movements of the machine. And after that, it is very similar to the swing angle estimation. We use a local minimum finder. Definitely all possible local minimum points are not representative of the digging depth of the operation. We use the prominence value and a thresholding method, also method to detect the correct points. And finally, we have the correct digging depth. In this slide, you can see the bucket position estimation approach by using the angles of the relevant joints and the kinematics of the excavator. We can easily calculate the position of the bucket. In this part, we will talk about the data collection procedure in our work site in Novatron company. We use a Komatsu PC 138 US model. The operating weight is 14,000 kilograms and the bucket capacity is 0.37 cubic meters. The sampling frequency for the data collection is around 200 hertz, and we use two types of the material, sand and rough gravel, for the data collection. In the figure 6, you can see our excavator in our work site in Finland in Novatron. And in the figure number 7, you can see the placements of the cabin encoder and also the IMU sensor on different parts of the machine. One IMU sensor on the bucket, one arm, boom, and also on the cabin. And the experiments in this paper were done by me. I'm very inexperienced operator. But for the results section, for the first scenario, we try to collect some data by using the rough gravel, and we try to fix the swing angle around 60 degrees, and the digging depth is not under the ground. It is the material is under the ground. It is surface. As you can see in the figure number 8, the method can correctly detect the correct scoping and dumping position, and after that, by using the difference between them, we can say what is the swing angle of the operation. As you can see, it is around 60 degrees. In the first scenario, also we apply the digging depth estimation methods. As you can see in the figure, there are a lot of local minimum points in our real data set, but the method can easily detect the correct digging depth by using the prominence value and also method. But for the second scenario, we try to fix the swing angle around 120 degrees, and the type of the material is sand. In this experiment, the digging depth is under the ground. As you can see, also the method can correctly detect the correct maximum and minimum points, and after that we can easily calculate the swing angle of the operation. And for the digging depth estimation, again we can see that the method it can easily detect the correct digging depth, not all or incorrect minimum points. In this operation, the digging depth is around -2 meters, but for the previous one, the first scenario, it is 1.05 meters compared to the reference coordination of the machine. And now we have the conclusion. Firstly, we talked about the excavator productivity and it is priority. It is important. Why it is so important for the improvement. Without measuring the productivity, we cannot say we are going to improve the machine and operation. And we talked about the excavation operation. What is this operation, and why the quantity of the material and operation cycle time is important. After that, we talked about the different operation conditions that can significantly affect the productivity of excavator in the excavation operation. We proposed our idea for the swing angle and digging depth estimation by using the some ideas, prominence calculation and thresholding method by using the OTSO. And finally, we had the data collection step in our work site, and finally you saw the result. And finally, I would like to talk a little about our project. Actually, there is a there is more project that is funded by the EU. There are 8 researchers that work in different companies and also in different universities on the robotization and automation of the heavy duty mobile machine in different application and different universities such as Karlsruhe Institute of Technology, Tampere University, and are working with big companies such as Volvo, Novatron, Liebherr. Probably in the future, you can see more about the MORE project and its results. Thank you so much.
Okay, Molaei, thank you. Thank you for your presentation. Very nice. Thank you. Questions here in the auditorio? Yeah, we have one question.
Thank you. I have two questions actually. Like, by the way, nice presentation. The first one is, have you made any comparison, or do you have any information of like this method in comparison with some model-based estimation? I don't know, camera filtering or something like that for the swing-based estimation, because I see what you are focusing in is more just purely during the measurements, but not really considering the model base. So I wonder, like, if you made any comparison in that regard. And the other one is regarding the digging estimation, also more or less for the model base. If you had a plan of constitutive models for, or if there any room for constitutive model inclusion in this method that you propose. Thanks.
Thank you for question. For the first one, actually for the comparison, we didn't have any idea or any model to be easily able to compare for the excavation operation, because there is the behavior of the operator can easily change the operation, and also for the material can easily change. There is no accurate and complete mathematical model for the excavation operation, and because of that we try to focus on the measurement, and we use the measurement to able to calculate the swing angle and digging depth in real-time mode. And for the comparison, because there is no other ideas or no other papers or other mathematical model, I didn't have any idea to compare my method with that. But for the second question, I didn't exactly understand your question. Please explain more. Thank you.
I just think that for for the machine soil interaction, there are like some constitutive models that tell you like how the soil reacts to some influence, and I was just wondering if like there is like some possibility for your research, because I think it could be quite fitted for what you're doing to include the some behavior of the soil on it. I was just wondering if you have some idea in that regard, like if you are researching in that regard in the future.
For the, I agree with you. There are some model for the soil interaction, but actually in our paper at this moment, we do not want to consider the soil, and only we want to consider and to analyze the effects of the digging depth on the operation, not the type of the soil. But you are agreed that, but using some kind of soil interaction models, we can get some ideas about what is the current type of the soil. But at this moment, we only focus on the digging depth without considering the type of the soil or other models in this field.
Thanks a lot. Really interesting topic.
Okay,
Thank you so much.